election, chair-elect, and future chair. Welcome for our participants. First of all, I will invite Dr. Mohammed to introduce this webinar and the context of this webinar.
Thank you, Dr. Ilham. Good morning, USA. Good afternoon, Tunisia. First of all, I would like to thank our partner, IEEE, as well as our dear speaker, Charlotte and Samantha. This webinar is being held as part of the Munich Expo that is taking place online this year exclusively. The University of Sfax values 3D printing technology immensely, and we believe it's the technology of the future. And we are trying to popularize our Fab Labs in our institutions. I would like to remind that our researchers and our students have developed many solutions to add healthcare professionals as well as enterprises, which you can find in our website. I hope this webinar will be beneficial for everyone, and thank you. Please, Dr. Ilham.
Thank you, Dr. Mohammed. During this hour, I don't know if you will watch as a presentation or some videos, or we'll talk together, discuss together, and we present your dream, your big dream of 3D, of really 3D, which become a reality. I had the occasion this morning to visit to watch some videos and to visit your website. It is very, very interesting. And via this webinar, we want to learn a lot from your experience. So let me present with more detail Samantha, or you prefer to present yourself. Perhaps I haven't the occasion to stress on your competences or your preferences. I would like to give you the opportunity to present yourself. Also, for Charlotte, please, the floor is for Samantha.
Good afternoon, Tunisia time. It's so nice to meet you all over video. Oh. Good afternoon. Can you hear me now?
Yes.
Oh, great.
Thank you.
Great. Well, I can't say it's just such an honor to connect with you and your community over video. I am a big fan of all of the amazing work in entrepreneurship that is occurring in Tunisia, and hope that someday I can visit in person. But I'm Samantha, so I was really honored when I was a student to co-invent something for life sciences. We called it an artificial immune system. It was a pretend bone marrow, and we grew stem cells in it for over a year. I started a company after college and sold it, and then had the honor of working for NASA, where I was involved in innovation stuff with space life sciences, and then became really excited about entrepreneurship in space. So I became the social entrepreneur in residence for NASA headquarters. While I was at NASA, I volunteered with Engineers Without Borders, which some of you may participate in as well, with NASA's chapter, and had the chance to travel to East Africa and Central America. And my now co-founder Matthew and I were very passionate about this idea of making a tool that can assist in manufacturing so that people could use 3D printing to print big things affordably from garbage. So that has resulted in us leaving NASA to start Re3D. We make the Gigabot. It's the world's largest affordable 3D printer. It's very modular, it's open source, and allows us to print with filament that some of you guys may have used in the Fab Lab. And thanks to some of the votes maybe you sent in and the grants that we won and our sales, we've now been able to make a second version of Gigabot that allows you to print. This is shredded up water bottle. So it allows you to print with flake or with pellets. So we're so honored to be printing with garbage and non-garbage in many formats with users in over 50 countries now. None yet in Tunisia. There's, I think, one in Egypt and a few nearby countries. But we're so looking forward just to sharing a little bit more about what we do and how so many of us have been working to make PPE during COVID. I'll let Charlotte share a little bit about her background.
Thank you.
Hi, everyone. My name is Charlotte Kraft, and I work with Samantha at Re3D. I've been lucky enough to be involved with this company for a little over a year and a half now. And my role here is to help engage with our community and enhance our education programming and connect with people all over all of our communities, which now is all over the world, to help ensure that people are able to use 3D printing in the ways that works best for them. So a lot of what I do is share the Re3D story with new people. We do a lot of virtual tours of our factory to help educate people about 3D printing and how they can 3D print from waste and how it's really possible. It's not just a dream anymore. We've really made it happen. My background prior to this actually was very different than Samantha's. I went to the university for a theater and dance degree. I have a degree in dance and theater performance. And then I spent almost 11 years working in performing arts administration in the nonprofit world. So I did a lot of creating and a lot of producing unique, interesting works. And a lot of the works that I made were multidisciplinary and very technology enhanced. So, you know, I might have a dance performance that would also be using a live music performance and syncing video and also creating an interactive set. Like one of my most favorite performances that I was able to produce used a giant contraption that moved and shifted along with the music, and it was manipulated by dancers, and it was designed by an architect. So, you know, like these interesting, like unique immersive performances is what I did. And I felt a couple years ago, I decided that it would be good for me to like do something that was more impactful, more service oriented toward the world. And I started looking around, and at the same time, I got into 3D printing as mostly as like you know, an art exercise for myself, an exploration to create different things for myself and for my community. And I found out about Re3D, and I learned about its mission, and I kind of fell in love with it. And thankfully, at the same time, Samantha and Matthew, the co-founders of Re3D, were looking for someone to help expand their community engagement. And I, with my nonprofit background, thankfully was a really great fit. So I joined the team. So that's a little bit about me.
Thank you very much. So the idea to deal with this project come from arts for you for the first time.
Oh, I'm sorry, could you repeat the question?
The idea to deal with 3D printing for Charlotte came from the art printing. for the first time. It is for art printing, for cinema, for art print. For Charlotte, you hear me?
Yes, sorry, I can't unmute myself, so I just had to make a request. I'm trying to stay muted here because my kids are in the background having a party, so I didn't want to overwhelm anyone. Yeah, so my interest in 3D printing came from the artistic side. I actually, the very first thing I ever 3D printed is I made a prop for a costume. And I love the idea of like the fact that 3D printing opens up the art world to kind of like, you know, the endless possibilities of art that already exist in a new way that's technologically enhanced.
Yes. And for you, Samantha?
Yeah, for me, I had used 3D printing to invent my first device for stem cell research. It was a much more expensive printer, it was bigger. And then when the open source movement started, the maker movement around 2009 and 10, my co-founder Matthew, who was a friend of mine through Engineers Without Borders, showed me his printer bot, and I printed a little green toilet because I've always been just fascinated with conversations around sanitation and improving quality of life. And I thought it would be great if there was a toilet-sized 3D printer. So a printer that could make a toilet. So to be funny, I made a smaller toilet.
If you guys would like, we do have a presentation we can share to kind of like talk through our COVID-19 response and how it worked with our 3D printing company. We can do that. But I think, let me just see. Yeah, if you make Samantha a co-host, which you can do by like hovering over her name in the participation bar and clicking more and then click co-host, she'll be able to share her screen.
Oh. Oh, it looks like I can do it now. So I'm going to desktop and share. And then I'm going to go to, oops, let me see here how to do this. Let me get this out of the way. There we go. Slideshow play from start. Oops. You'll have to apologize. We apologize. We're using another presentation. Oh, is that echo still there for you? Hopefully it's better now. So just for context on how we got into this, again, where there are many types of 3D printers, you may have used more than one, and they have different benefits. For us, where we sit is in this in between, where there's the desktop printers, which are small, and you may have some in the Fab Lab, and then there's the industrial systems that are very large and cost a little bit more money. And so we're in the middle, in that affordable price point. And for us, the reason that we became really invested in the 3D printing conversation for PPE is because we have these very tall 3D printers that can print from different types of materials. It allows us to print a lot of one thing at one time. So instead of having to do a print and then take it off and start a new print, now you could do maybe 10 or 20, or in terms of, this is a little ear guard we made, we could do maybe 50 of them at one time. So people were very interested in our platform, and then they're a little more affordable to operate. And that was really aligned with our mission because we are a spin out of Engineers Without Borders, NASA Johnson Space Center. So almost all the decisions we make are around our mission, which is to make 3D printing accessible, and this vision to help people innovate wherever they may live. So today we're going to tell you a little bit about what we say dream big, print huge, how we went from making objects, we sell both the printers and the services for industry or academia, to shifting and making PPE. The other interesting thing about our company is because we've been around for a few years now, we have customers all over the world in 50+ countries. And so while we were being asked to print PPE, so were our customers. And some of our customers experienced COVID impact before we did. So when we started making PPE, we saw on social media that so were our customers in Turkey with their machines, their big 3D printers, and our customers in Senegal, and our customers in Kenya and Nigeria, and all over Europe. So we've been able to learn from our customers as we all work on what is very much a shared global problem. The other interesting thing is, some of our customers were manufacturing companies or in oil and gas, and some were in education or art and design. Some were perhaps already doctors, and some were just makers or doing rapid prototyping. But all of these customers that had access to their big 3D printers were being asked in their community to make PPE. So it was a really interesting way to see people from all different backgrounds come together if they were able to go to their work or their studio or their lab and use their printer, or maybe they had one at home. And then there were many platforms that stood up to help people communicate in their language and help share resources, as Helen will talk about. So we had this community. It was very broad. People were doing different things with the same machine all over the world. And then COVID hit. And I'll turn it over to Charlotte and advance the slides as she talks.
Yeah, exactly. Everything changed when COVID happened. Many of you might know this story, but I'll share it for everyone's education. So as COVID was kind of spreading across the world, and specifically as it hit Italy, where they were one of the first European countries to get hit pretty badly by the pandemic, there were hospitals in remote areas, right, mountain regions, and they needed to use ventilators for their patients, as we all know that's important, but they were running out of parts for their ventilators. So a local 3D printing company kind of reverse engineered one of the parts for the ventilators that they were using, and then it got out in the news, right? They shared out that they were using 3D printing to replace parts they couldn't get copies of because all of the local supply chains were distributed. So that inspired the open source 3D printing community, of which we're a part of, to start forming all of these ad hoc groups online. And there were a bunch of different groups that formed up, hundreds actually, and we joined in right at the beginning with a lot of them to try and help make sure that we were participating and giving back to this community that's given us so much as quickly as we could. So we joined up with a few different groups to kind of track what was going on, but we also paid attention to what was happening locally. So in our area, in Houston, we have offices in Austin, Houston, and Puerto Rico. So in Houston, there is a local fabrication lab called TXRX Labs. And they similarly joined up because they also use 3D printing, and they put out a call in the city for local makers to join in, even people who just have 3D printers at their home, to make a very specific design of a face shield. Could we have the next slide?
I'm trying here. Oh man, you just had to see my desktop. It's not letting me advance anymore. Give me 1 second. Oh, let me try this button. Oh, here we go.
There we go.
User error.
So that's all right. The great part about having an open source community start additive manufacturing is that it can be fast, it's accessible, you can make custom solutions, you know, specifically the doctors in Italy were designing a part specifically to the ventilator they had, but you know, everybody has ventilators made by different companies. So you need to be able to very quickly support your local groups in what they need locally, right? So that's how you kind of circumvent the traditional supply chain to make that work. Plus you can do it open source, which means that you're not trying to make it for profit, you're trying to use it in service of humanity. Next slide. Some of the downsides though, is that, you know, because the open source community is mostly people who are doing this not in a healthcare setting, that you're not necessarily communicating directly with the people that you want to help. And then you can also like look at PPE and make different interpretations on it depending on your level of experience with what PPE is. So you can kind of make decisions that might not be in the best interest of the users. There's also potential problems where, all of these people are just trying to make things out of their house. You have to have a way to organize it and project manage it. And then another one of the big challenges, especially with the most common way of 3D printing, which is fused filament fabrication, which is using plastic filament to 3D print. There's not a lot of research out there that talks about how to sterilize those parts to make sure that the parts that you're using are going to be safe, especially in healthcare settings. Next slide. So on the list, we already talked about ventilator parts, things that were needed by in the COVID-19 pandemic. There's intubation boxes, so boxes that you would use to protect the healthcare worker as they intubate a patient. And when you stick a tube down their throat, there's a possible for a whole lot of aerosols to be expelled. So you want to protect the healthcare provider while they're doing that. That's what the intubation boxes are. Face masks were an obvious issue because very quickly everyone ran out of their N95 face masks and needed more supplies. So that was a potential issue. Next slide. In addition, all the other PPE things like gloves and gowns to protect your skin, and also face shields to protect your face from aerosols. So the problem there is that not all of those things are good for using additive manufacturing techniques, right? You couldn't necessarily make a glove that would be as flexible as you need it to be for PPE use out of 3D printed plastic, right? Similarly, you couldn't make a gown with a fabric type need out of a 3D printed plastic. Also, additive manufacturing plastics don't naturally filter anything, right? So masks become a challenge because you would still need to make a filtering material part of your mask design. So not everything had a good use, but we circled in on face shields because face shields can be made out of plastic, they can be reusable, and they can be cleaned if you make them right. So the parts of the face shield that we focused on were the headband part, the part that connects to your head, the clear plastic lens, and also sometimes an elastic band. But we came up with a solution to solve that. We'll show you in just a second. Next step. All right, so this is Zippy Shield, the shield that Re3D invented. And as you can see, it's got a really unique kind of closing mechanism so that it can be completely 3D printed and 3D printed out of PETG, which is a material that can withstand some intense sterilization techniques. And it has a kind of cool clasp closure, kind of like a zip tie. That's where the name came from, actually. Next slide. So like we said earlier, not coordinating with your local healthcare providers, it creates potential issues, right? So we took the stance very early on that we wouldn't create anything for the COVID-19 pandemic unless we were doing it in direct connection with healthcare providers who could advise and help us make choices. So we connected with some local doctors who were looking for face shields and started from there doing a consultation with them about how to make this design work. So they had very specific requirements. That's okay. One, that it fit a variety of sizes of heads. 2, that it covers the face from the front of the ears forward, and 3, that there weren't any gaps in the top, so that there wasn't an open area where aerosols could come in from the top. Next slide, thanks. Additionally, again, because of supply chain issues, there was a shortage of the clear plastic that you needed, because everyone wanted to help make PPE. Everyone was using the same kind of 0.25 inch clear plastic PETG lensing, right? And cutting it to fit. And so when we started connecting with our suppliers, they were like, we don't have any of that clear plastic available. However, we do have an excess supply of these clear plastic lenses that were made for these construction variety face shields. So what if you designed something for healthcare that would use these shields? And so that's what we did. We used some existing supplies in our local network to create a new design. Next slide. Thanks. So with our local healthcare providers, we wanted to get out of the gate quickly. So the first thing we did was gather up all of the existing open source designs that were out there and presented them to them as options that they could use. So we presented all 3 of these different designs to them, and they liked parts of them, but they didn't find one that was perfect, which made it necessary to move on in the prototyping project. Continue. So what we did is, like we said, we identified what they needed. And then our engineer, Helen Little, created a design in SolidWorks and then 3D printed it. And then we had a virtual call with the doctors and also 3D printed physical prototypes that the people who were actually in our factory could wear. And everyone kind of communicated virtually to discuss the pros and cons of the design. And then we iterated again. So the feedback turned into this looping iteration process. And eventually we actually ended up with 10 different versions of the design. It went through 10 different iteration steps to finally get to the completed design. Thanks. So yeah, so this is what the final Zippy Shield looked like. You know, the original one was completely closed to the headband, but that was a problem for flexion. We had people with very large heads trying on the headbands, and we had people with very small heads. And by simply making that kind of like cutout space at the very back where it connects to the ears, that allowed the band to be more flexible, to curve around the most smallest heads. And the zip tie closure allowed you to make it as tight or as loose as you needed for comfort and size. So one of the things we had to do is, because we're a company, not a nonprofit, is figure out how to make this thing affordable, but also make sure that we were assessing the price. So we at Re3D have a spreadsheet with all of the information about how much power our printers take up, how much electricity costs, how much lighting costs, all of that stuff calculated into like a cost per hour. And we use that to calculate all of our 3D printing costs, but then we made it basically at cost. So this is basically the at cost, cost to produce one Zippy Shield is $5.72. I'm going to hand this back over to Samantha to talk about this section.
Sure. So as you know, we were making solutions for doctors, and as different platforms were standing up for makers to come together, there are many federal governments, the US federal government, the Canadian government, many countries in Europe, and then the EU Commission recognized that we needed to organize, because sometimes too, when we were making these solutions, people were spending a lot of time, like we did in all of our revisions, making the exact same design. And you know, when there's so much urgency, it's beneficial to provide a place when people are doing their research to see if there's already a solution out there. And then the US government realized there was opportunity to provide what we call emergency use approval or community approval, to advise on designs that maybe could be used in a hospital setting, or designs that had to be used with certain materials to be safe, or that were only recommended, say, for community applications. So there was a resource that stood up in the US. It's called the NIH 3D Print Exchange. And in just a couple of weeks, there were thousands of designs submitted, which goes to show how many people were doing this on their own. And that's become a really good resource, and we use it too for guidance on what's safe, and it is reviewed by the National Institute of Health. And there are other equivalents around the world as well. So we uploaded Zippy Shield and then some other designs that we'll highlight as other clinicians and community shared their 3D printing needs. So in parallel, as some of your community may have seen, there's been contests throughout the African continent and Europe. I haven't seen any in Latin America, but I'm sure they were going on. And in the US and in North America, to make 3D printed solutions that could overcome common pain points that people were seeing. So for example, a number of groups were focused on 3D printing masks in the beginning. And unfortunately, a lot of the masks, just like we saw with the face shields early on, did not fit the mouth very well. So it would allow air to come in. So there was a challenge that was posted by an organization called America Makes to make a better fitting mask. So we printed a mask that was made out of flexible material, so it could bend, that had a shape that could fit those tiny heads, as Charlotte mentioned, as well as larger faces and facial features as well. And we didn't win, but we were very honored to be a runner-up, and it was then placed on the print exchange for community use. And then as one thing that we were noticing and the open source community was noticing in our customers is, many of these 3D printed solutions also require other materials. So with the example of this mask, there's a filter that's recommended if it's to be safe. And then there's that elastic strap that has to go around the face. And, with the face shields, there's the plastic. That's why many people were innovating to take multiple forms of plastic. And it wasn't uncommon for suppliers of these materials to run out, or even the materials for printing. So one concept we came up with was to take a shipping container and to put in all the requisite supplies maybe you would need for 1 week for PPE production, as well as our large printers, so you could print a lot of them with a generator. We've since we applied with this concept to the Department of Defense, who in the US was responsible for providing the support to hospitals in the States. But we've since seen opportunity to work with groups, say like USAID or the International Red Cross, and other groups focused on capacity building or disaster response and resiliency. And other groups have been thinking about this too, in terms of, how could they turn maybe their university that's in lockdown right now into a central, manufacturing hub or resource center to put resources together in order to address the raw material needs. And this is, this chart here, this pie chart, is a little bit outdated, but it goes to show when you combine resources, how much more effective you can be. So we really started working on PPE production like the last week of March, and that was more of the iteration stage. But in just a few weeks, this is taken as of April 20th, Re3D, in addition to making our factory and our offices in Puerto Rico, Austin, and Houston, served as drop-off locations for other people working on designs. And together you can see that we did so much more than any one of us would have done on our own. Charlotte continues to meet with these organizations every Friday just in the Houston area, and we're still sharing materials now 4.5, 5 months later, which is crazy. And so I think that what it shows is that, as a maker and as an entrepreneur, particularly in a global crisis, like connecting with other communities can help you be much more effective. In addition to focusing on hospitals, the other request that we've seen in the United States, and I don't know if it's the same where you live, is that doctors aren't the only people that need PPE. So thinking about people in sanitation, that drive buses, that work with food and food delivery, they need PPE as well. And a lot of that was prioritized to the hospitals. So Initially, we formed PPE for the People, which is a campaign with Impact Hub, and have also been doing donations to dentists and other professions that also need PPE to help groups reopen safely. And that's been kind of interesting, as you know, sometimes businesses reopen and then they close and they have to reopen again and comply with local rules about how to keep their employees safe. It's also forced us, or given us the opportunity to look at other solutions, such as flashcards. Not everything has to be 3D printed. So thinking about your fab lab, you may have access to a laser cutter. And so there's been a number of groups that have been working to take sheets of plastic and to cut them to form a splash guard, so a barrier similar to those intubation boxes for workers to protect themselves from COVID exposure. And then because so many people are wearing masks, particularly those individuals that work in locations where you have to wear maybe 2 or 3 masks over each other, it can be hard on your ears. So we've been working on comfort straps, which again could be 3D printed or could be fabricated in other ways. And then another application that I'm personally really passionate about is contactless door pulls. So looking at ways you could install something over a door handle. So you could open it, say, with your forearm or with your elbow, and you wouldn't have to touch the door. So again, just thinking about ways that we can creatively limit exposure, not just for doctors, but the community as we resume our activities after COVID. So we have many more use cases. Charlotte did a great job collecting stories from some of our customers that we're sharing all over the world. You can find them if you go to our website, re3d.org, or any of our social media is at re3d printing. And we would love to hear your stories and highlight what you are doing, regardless if you're using our printer or if you have a need. We want to share that with the global community because many of us are still producing PPE today. I know we are, because the need is just so great. So we'd love to answer any questions that you may have. I hope this was helpful in framing what we see makers doing with PPE and 3D printing.
If you have a question, feel free to just put it into the chat and we'll answer it live.
What do you do to reuse products after use? That is such a great question. We are a little bit unique in that we have a printer that can take the shredded up plastic. Even so, if you make something out of filament and then you decide you don't like it anymore, you can grind it up. And we in Austin and in our Houston offices, we have access to a grinder. So we can grind up the print and then print something else. Maybe it is more PPE, or maybe it is a chair like you see here that we made for Habitat for Humanity. But you know, there still needs to be research on the number of times that you can grind up and then 3D print an object and then do it again, and make sure it's safe, particularly if you're in a healthcare setting. So that's something that we want to explore. You'll probably see us applying for some grants because I think that's important. We don't want to make more garbage, but I think the reality of it is with PPE, you've made a lot of single-use disposable items, and while we're very focused on sustainability, we have probably contributed a lot to landfills and our customers over the last couple months. Also, if you've been printing PPE or making it, feel free to share what you've been doing in chat as well.
What are the limitations of 3D printing? Yeah, good question. So like we were talking about earlier, especially as it applies to PPE, Some of the challenges are that 3D printing layers of plastic creates porous openings in your PPE, right? Porous holes where potentially bacteria could get inside and make it hard for it to clean. So Prusa, the 3D printing company, did a lot of research because they wanted to make sure that the objects that they were making were safe for use in hospital settings, right? So what they determined is the best way to sanitize 3D printed objects made from PETG is to immerse them in a solution so that the solution kind of penetrates all of the holes and potentially kills any bacteria that could be inside of there. But that's only one type of material that was validated. And there are so many different types of plastic that you could use to 3D print with. And some of the challenges is that those different types of plastics are have different chemical makeups. And so stand up to, bleaches and hydrogen peroxide and all of those different chemicals in different ways. And some of it completely degrades those plastics. So it makes it harder to use, right? Another limitation is that sometimes the raw materials are really expensive. The PLA that most people use is the least expensive raw material, right? But the more complex polymers, like the flexible materials that we use to make masks, actually made it much more expensive than even an N95 mask might cost, because of the cost of those raw materials, which is why as a 3D printing company and as a company interested in sustainability, we are trying to find ways to make that more affordable. We're trying to find ways so that you can reuse the material that you already have, or maybe even reuse the plastic in your environment, granulate your water bottles, granulate your excess food packaging once you've cleaned it, and use that to 3D print with.
Okay. Okay.
Some validation before manufacturing or no? الو مش اسمه
ما تسمع فيك يجينا احنا صوتنا we couldn't hear you قالت نرجع نحل الميكرو هيك اوكي تسمعنا.
Can you hear us? You can repeat your question?
Yes. For prototypes, need some accreditation before manufacturing or not? Especially medical.
حط الفيديو. Yes. Okay. Thank you very much. Mohammed has a question.
Yes, for prototypes, especially medical, need some accreditation or some validation before manufacturing or not?
From health workers.
Yes, exactly.
I have the same questions. How do you assess the face shield of the PPE? Is it by experience return or have you now an assessment system in the laboratory condition? It is
Yeah.
the same question. How do you validate the product?
That is a very good question. I think when COVID hit each of our regions and makers all over the world were asked to help, initially there was less validation. But then, you know, in every community we are learning in 2 weeks and 1 month, the local government and regulatory groups realize that there had to be a system. So there are several systems now in the United States. It is called the 3D print exchange. And so the National Institute of Health and the Food and Drug Administration and manufacturers look at designs and then give them an approval for either community use or hospital use, and say if there are certain materials or settings that have to be used. So that is how in the US we do it. And in many regions we are learning there are similar systems. What we decided as a company and as makers is we would only work on solutions if we were approached and working directly with the doctor. So we were a little bit slow to get plugged in because we were very nervous that we might hurt someone. But as Charlotte shared, you know, even with approvals for the initial design, there is still a lot of question about sanitation, and because we know many doctors, especially in regions that just don't have enough, are going to reuse the print even if they're told not to. So some people are saying maybe you can bleach it 5 to 10 times and use it again, but there's, you know, this is one of those things that was very reactive and now there's guidance, but there's still, I think, a lot of research that has to be done so that if 3D printing is ever needed for an emergency use, again, we have more systems in place to do it safely. What would you say, Charlotte?
Yeah, that's exactly right. I mean, so on our end, you know, we use the NIH and FDA. So the FDA, Food and Drug Administration, is the one that authorizes products to be used in hospitals. And they basically have different tiers of the level of testing an item needs, depending on what it's being used for. And so, you know, we submitted it to the exchange and then they did the testing and validation on there. And that's how we do it. We did it. In the case of Prusa that I mentioned earlier, they actually connected directly with laboratories and came up with testing systems and then posted all of the results on their website for all of the various chemicals they used for sterilization and whether it was positive or negative. And they used, you know, the government entities and research laboratories in their country to make that happen. So, you know, everyone's kind of doing it differently. But yeah, I mean, the first step is to make sure that you test it with healthcare providers and the end users in mind to make sure that what you're providing is going to make sure that they're safe and comfortable and still able to do their essential work.
We have a question here in the chat from Hiba. What are the limitations of 3D impression?
Yeah, we.
I can add also what are the perspectives of 3D impression, limitation and perspective.
We did address Hiba's question before. Did you need some more clarification, Hiba? No, she, I think she's okay. So, sorry, what was the second part of your question?
The perspective, limitation and perspective.
Yeah, I mean, I would say that it's unlimited. That's the great part about 3D printing is you're only limited as far as your imagination, right? And there are many different forms of 3D printing that can help be a solution for whatever you're making. And we particularly work with plastic polymers, but there are other forms of 3D printing that works with metals and resins and all sorts of different solutions. So there's a tool in the 3D printing or additive manufacturing toolkit that will probably help you get there. But it's a great complement to all of the other manufacturing systems that already exist out there.
Thank you. Some other question?
Yeah, Hiba has another question. Does 3D printed masks also provide the same fluid barrier protection and air filtration as other cleared surgical masks and respirators? So it depends, right? It depends on the design of the mask. It depends on its fit to the face. Samantha was talking about how the mask that we designed that was flexible fit multiple different face shapes. And that was, the reason was because there's that issue that, if it doesn't fit to the face in a flush way, then that any air you exhale is going to go through the path of least resistance, right? It's going to flow out through any gap in that mask, right? And as long as you have a filter material, and part of the reason people wore 3D printing masks is so you could take an existing filter material like a surgical mask or like an N95 mask and cut it up into smaller pieces so that you could reuse that very in short supply, limited supply material as the filter for the mask. So it does depend. It depends on the mask that you use, and it depends on how it fits the person, specifically the face that it's going on. So everybody's faces are different shapes. So everyone who uses a mask for any form, whether it's 3D printed or not, needs to make sure that they know how to get it on their face and make a tight seal around their nose and mouth in order for the filtering to be functional in any way.
Thank you very much. I think that it is time to close our session. Thank you very much for your amazing presentation and all these clarifications about 3D printing. I hope we will be able to collaborate together with Tunisian researchers and Tunisian engineers via, why not, IEEE. Yeah. We are very active here, and we are able to collaborate and to create the representative startup of really 3D, why not, here in Tunisia, in Africa. It will be a good project here to serve Africa and the Middle East. Why not? Absolutely. So we are always here, and we are always volunteer for new horizons and new experiences. Thank you very much.
Thank you.
Thank you. Thank you, Samantha. Thank you, Charlotte. And see you and keep in touch.
We will. We'll do. Thanks, everybody.